Hi friends, in this video let us check out how to draw a sphere in isometric projection as well as isometric view. Now I am taking the example of a sphere being kept over a rectangular lamina, that means rectangular area. Rather than a rectangle, it's considered to be a square plane. Just imagine a sphere is kept on a square plane, a square sheet of paper or a square plate without any thickness. This is exactly problem number 17.30 of your engineering graphics textbook. Now let us go for drawing the orthographic view of that sphere. That means its top view and front view. I am drawing the square plate initially. See, in general, the questions will be of two categories. You will be asked to draw the isometric view or else isometric projection. In isometric view, what I have said already, that means no dimensions has to be changed. Only you have to draw the 30-degree isometric axis and take all the true dimensions as such as it is given in the question. But while drawing the isometric projection, you have to multiply each true dimension using 0.80 and take the new dimensions while drawing the isometric projection. But in the case of sphere, there is a little change here. Now, when you are drawing the projections of a sphere, while going to draw the isometric projection, the radius of the sphere is not going to be changed. That means if a sphere of a particular radius is given in the question, you have to take the same radius while drawing the isometric projection of a sphere. Be careful, this is applicable only for sphere. But in the case of isometric view of a sphere, here the radius of the sphere should be multiplied by 1.22. The value is 1.22. While drawing the isometric view, you have to multiply the radius of the sphere using 1.22 and change the radius to a new value, then take the new value and draw the sphere. This is the case for only spheres. Be extremely careful about that. So I have drawn the square now, square plate, the top view of the square plate. I am taking the midpoint of the square plate as the sphere is kept centrally over the square lamina or area. The midpoint axis is being drawn parallel to that particular edge. Now taking the radius and keeping the center, I have drawn the circle and named the square as ABCD and the center of the circle as 0. This is the top view. Now when we draw the front view, the square lamina, square area will be viewed as a single line because that is an area without any thickness. And from that center point, the namings are given accordingly now, and from that center point you have to take the height up to the center of the sphere. The height up to the center of the sphere will be exactly same as the radius of the sphere. Imagine a ball is kept on a table, and if you view it in the front view, to mark the center of that ball you have to have a distance, a height. That height will be exactly equal to the radius of the sphere or radius of the ball. That is the same value that we are taking here. Same concept is being applied here. I am marking the center point. And now the sphere is drawn using that particular center point. The orthographic views, that means the front view and top view, are over. The dimensions of the sphere is being marked. Radius of the sphere 30 mm. So the point O dash from that horizontal line, that distance also is equal to 30 mm only. Dimension of the square is also being shown. 75 mm. Now you know the starting procedure. Whether it be isometric view or isometric projection, first you have to create the isometric axis. For that we have to draw a horizontal line, take a point on the horizontal line, and from there we have to mark the two isometric axes. I have selected the point. Now I am drawing the isometric projection now. Hence, the distance of that particular side is multiplied by 0.82. That means 75 into 0.82. I am marking the isometric projection of the square first, square plate first, so it will look like a rhombus. And now the edges of that square will have the length equal to 75 into 0.82. See, 75 into 0.82, you can clearly see at the top of the video. 75 into 0.82 is equal to 61.5. The value is taken as 61.5. Now I am locating the center of the rhombus. Now on the center, now I have to draw the axis of the sphere. Now from the center, the height up to the axis will be equal to, the true length was 30 mm, the radius of the sphere. Now that particular height is also changed to isometric axis, that scale, sorry. That means 30 into 0.82, you have to take 24.6. So from the center point, the perpendicular distance to the top, I am marking the perpendicular inclination, and the value now I am taking is the value of the height of the center of the sphere from the square lamina. To mark the center, we have to take that height. That height is multiplied, that means 30 is multiplied by 0.82, and I have marked the center there. Now, in the isometric projection, all the other true dimensions of the objects have been multiplied by 0.82. But while drawing the projection of the sphere, the radius is kept as 30 itself. You don't have to multiply the radius of the sphere using 0.82. You don't have to multiply, because in isometric projection of sphere, the radius of sphere will be kept to the same true value. See, that particular value, see, the edge DC or the edge of that square is now 61.5, but the radius of the sphere will be, see, the height of the center of the sphere from the center of the square area or lamina is again changed to 24.6. 30 multiplied by 0.8 to 24.6, but the radius of the sphere will remain as 30 itself. See, this is a special property that is applied only to in the case of spheres. That means isometric projection of a sphere will have the same radius, only the sphere. If it is resting on a square lamina, all the dimensions of the square lamina will be multiplied by 0.82 definitely. In the isometric projection, the radius will remain the same. It's only the case for sphere. And as it is isometric projection, you have to always show the isometric scale there. In the previous video, we have discussed how to draw the isometric scale. Drawing a horizontal line, then taking an inclination of 15 degree from one side, one end point, and from the other side, other end point, you have to take 45 degree inclined line to the opposite direction. The horizontal line drawn now represents the true length. You have to divide the length into equal denominations, equal parts, and to that inclined 45 degree line, you have to draw parallel lines through each divisions made on the horizontal or the true length. So if the question is asked to draw the isometric projection, you have to mandatorily show the isometric scale. Isometric scale is just a representation. Okay, now let us get into drawing the isometric view of the sphere. So at the start, similarly we have to draw the orthographic projections, the top view and the front view. After that, while drawing the isometric view, first step is taking a horizontal line, then marking a point on the line and creating the two isometric axes. Now the isometric axis, on the axis we have to represent the two edges of the square plate. Now the square plate has original dimension 75 mm. So as we are drawing the isometric view, the dimensions of the square plate will remain as 75 mm itself. It will not be changed. A, B, C, D, I have marked the names. Now I am again going to find out the center of the rhombus. From the center I have to take the distance so as to mark the center of the sphere above the square lamina. So for that I have to mark the center of the sphere. I have to take the distance from the center of the square lamina up to the center of the sphere. Now that distance, as we have seen in the front view, is equal to 30 mm, which is the radius of the sphere itself. So that height, which is a linear distance, won't change its dimension as it is isometric view. So the distance will be equal to 30 itself. Distance will be equal to 30 itself. Now from the center of the sphere we have to take the radius. Now the radius is multiplied by 1.22 in isometric view. See, again I am repeating, this is the case for only spheres. For drawing a sphere in the isometric view, you have to change the radius to a new value. The new value will be the original value of the radius multiplied by 1.22. In isometric projection of the sphere, we have kept the radius of the sphere the same, but while drawing the isometric view, you have to multiply the radius of the sphere using 1.22. I am marking the dimensions. See, dimension of the square lamina is kept as 75 itself. That won't be changing as this is the isometric view. Only the radius of the sphere is going to change in the isometric view. The distance of the center from the center of the square lamina, height of the center will also remain the same 30. Now radius changed to new radius R1, which is equal to 30 into 1.22. Please go through the video once again. Thank you.